Since the definite integral represents the area between a function and the x-axis, we can also answer these questions if we're given the function's derivative in terms of a geometric view, like so with example 7. Here we're told that this is the graph of f prime, right? And we need to figure out what f of 1 is, if we know that f of negative 2 is 10. Right? So, using that same function building method, f of 1 is equal to f of negative 2 plus the integral from the point that we know, negative 2, to the point that we want, which is 1, of all the change. So f prime of t dt, f prime of x dx, doesn't really matter what the variable is there. Okay. So f of negative 2 we know is 10, so we're going to have 10 plus the integral from negative 2 to 1 of our derivative. So let's figure out what the area of the region from negative 2 to 1 happens to be. So here's negative 2, and here's 1 right there. So it's this triangle that we're looking at. All right, so that triangle, its area, well, the height of the triangle is 4 units, and the base of the triangle we see is 3 units. So what we're going to have here is 10 plus the area of a triangle is 1/2 the base times the height, or 1/2 of 12. So our final answer is going to be 16. Flip over quickly to the next page. With example number 8, this is more of the same. All right? We're given the graph of the derivative, right? And we are given an initial condition, and we're asked to find these 3 values. Right? So f of negative 5, well, that's going to be f of negative 7 plus the integral from the point that we know, negative 7, to the point that we want, negative 5, of our derivative. Right? Well, to go from negative 7 to negative 5, here's negative 7 right there, and here's 5, so we can see clearly that the area is 4. F of negative 7, we're told is 2, so this will be 2 plus 4, or a total of 6. To find f of negative 1, that's going to be the integral from f of, not yet. It's going to be f of negative 7 plus the integral from negative 7 to negative 1 of f prime of t dt. Okay, it's the exact same thing as what above it, except instead of stopping at negative 5, we're going to go all the way to negative 1. So negative 1 replaces negative 5 here, and it also replaces negative 5 in the upper bound. Notice that the lower bound is still the same, because that is our initial condition, or where initial condition takes place. So once again, f of negative 7 is 2, so we're going to have 2 plus, and then we want all the area from negative 7 to negative 1. Well, negative 7 to negative 5 is an area of 4, and then from negative 5 to negative 1, the area is 6. Now keep in mind that 6 is located below the x-axis. So what does that mean we have to do to it? Exactly, we have to negate it. So we're going to have 2 plus 4 again, just like the previous one, but then we're going to subtract 6. And 2 plus 4 is 6, minus 6 means our final answer there will be 0. So the first answer was 6, the second answer was 0. Now let's take a look at f of 5. See if you can write down the expression for f of 5 before I get it done. All right, did you replace the negative 1s with 5s? I think we had a few issues with the video there, which I apologize about. You can see the problem was finished off there. As far as f of 5 is concerned, we start with our initial condition, which is 2, and then we add the 4 and the 13 because those are regions above the x-axis, but we subtract the 6 because that's a region which is below the x-axis. 2 plus 4 is 6, minus 6 brings us down to 0, 13 puts us back up to 13, so the final answer for f of 5 would be 13.